How one small crack led to total structural failure. Welcome back to Blueprint to Reality, the channel where the smallest details reveal the biggest engineering truths. In structural engineering, not all failures begin with explosions or collapse. Some begin quietly, with a single crack. Today's video explores a powerful reality: how one small crack can lead to total structural failure. Introduction. Cracks are often misunderstood. To the untrained eye, a crack may look harmless, cosmetic defect, a minor imperfection. But to an engineer, a crack is information. Tells a story about stress, concentration, material behavior, load redistribution, and hidden structural danger. In this video, we'll uncover why cracks form, how they grow, when they become dangerous, real failures caused by ignored cracks, and how modern engineering prevents crack-driven collapse. 1. Why cracks form in structures. Cracks form when stress exceeds material capacity. Common causes: overloading, shrinkage and temperature effects, poor detailing, differential settlement, fatigue, and repeated loading. Concrete cracks when it is weak in tension. Steel cracks when fatigue accumulates. Cracks are not failures. They are warnings. 2. The danger of stress concentration. Cracks create sharp edges. These locations. Stress intensifies material behavior, becomes brittle, failure accelerates. Even a tiny crack can multiply local stress several times, trigger rapid crack propagation. This is why small cracks can become deadly. 3. From hairline crack to structural collapse. Crack growth follows stages. Stage 1. Initiation. Small, often invisible, caused by local overstress. Stage 2. Propagation. Crack grows under repeated loading, fatigue accelerates damage. Stage 3. Instability. Remaining material cannot carry load, sudden fracture occurs. Failure appears sudden, but it was years in the making. 4. Real-world failure. The de Havilland Comet aircraft. One of the most famous crack-driven failures. What happened? Small cracks formed around square windows. Repeated pressurization caused fatigue. Cracks grew catastrophically. Engineering lesson. Rounded corners reduce stress, concentration, fatigue must be designed for. This disaster transformed fracture mechanics. 5. Structural engineering case. FAU pedestrian bridge. A modern example of ignored cracks. What happened? Large cracks appeared before collapse. Engineers misinterpreted their severity. Structure failed under self-weight. Lesson. Cracks are structural messages. Ignoring them is fatal. 6. Why cracks are often ignored. Cracks are dismissed due to cost concerns, schedule pressure, lack of experience, misclassification as cosmetic. This human factor is often more dangerous than the crack itself. 7. Cracks and progressive failure. Once cracking begins, load paths change, adjacent members become overstressed, failure spreads. This can trigger progressive collapse, loss of redundancy, global structural failure. One crack can start a chain reaction. 8. How modern engineering controls cracking. Design stage. Crack width limits, proper reinforcement, detailing, fatigue analysis. Construction stage. Quality control, proper curing, accurate placement. Monitoring stage. Structural health monitoring, crack sensors, regular inspections. Cracks are managed, not ignored. Lessons for engineers and students. This topic teaches us small details control large outcome. Structures communicate through cracks. Failure is progressive, not sudden. Engineering responsibility continues after construction. A good engineer doesn't fear cracks. They understand them. Conclusion. Total structural failure rarely begins with collapse. It often begins with a thin line. A crack that was visible, measurable, and preventable. Structures fail not because cracks exist, but because cracks are ignored. If this video changed how you view cracks in structures, like, share, and subscribe to Blueprint to Reality. Comment below. Should we analyze a real crack failure step by step next? At Blueprint to Reality, We listen to structures before they fail. See you in the next video.